The major issue is context collapse. LLMs have finite context windows. They can't hold an entire workflow, all past actions and all state changes forever. They just can't. And so systems, they summarize. They compress history into shorter representations. That compression loses detail. And once a critical detail is lost, the agent starts making decisions on incomplete state. That's not a model problem. That's an information theory problem. And there's also a cost problem. That's a third one, because each agent step costs inference time, compute, and also latency. As workflows grow, costs scale linearly with steps, but exponentially with retries. If an agent fails 20% of the time at each step, a 10-step workflow succeeds only about 10% of the time end to end. That's brutal math. This is why real-world agent systems quietly add constraints. They reduce freedom. They limit tools per step. They predefine workflows. They add checkpoints. They force human approval, not because humans slow things down, but because constraints collapse the search space. The most reliable agent systems today are not fully autonomous. They are semi-agentic. Humans decide which workflow to run. Humans decide which actions are allowed. Humans decide when execution can continue. The agent fills in execution details inside those guardrails, inside those guardrails. This also explains why agent swarms don't magically solve the problem. Multiple agents don't reduce complexity. They often multiply it because agents now have to coordinate. Coordination itself is another branching problem. More math, more, unfortunately, choke points. So here's the takeaway. AI agents don't fail because they aren't smart. They fail because unbounded decisions are mathematically hostile. The future of agents isn't unlimited autonomy. It's actually narrow scopes, explicit constraints, strong state tracking, and human-in-the-loop checkpoints. The teams that succeed won't ask, can the agent do everything? They'll ask, what's the smallest decision space that still delivers value? That's a real answer, because that's the math.